Hello, space enthusiasts and tech watchers. Today we're diving into a captivating development in aerospace. Something strange is happening with Boeing's Starliner. Stick with us as we explore what's going on, why it matters, and what it could mean for the future of space travel. In today's episode, the twists and turns in the Starliner saga intensify. Meanwhile, China makes a significant advancement with the landing of its reusable rocket booster, and Europe achieves a milestone in its space exploration efforts with the completion of testing on their new heavy launcher. The Boeing Starliner capsule's journey grows increasingly bizarre as it faces another week of departure delays. Originally slated for a brief one-day stopover at the International Space Station, ISS, astronauts Butch Williams and Sonny Wilmore's stay has now ballooned to an unforeseen month. This extension follows a series of technical issues that marred their arrival at the ISS, disrupting the mission's timeline significantly. Originally scheduled for a swift return to Earth after docking at the ISS, the crew's itinerary was first extended to 2 weeks, then to 3, and now a month seems to be the minimum. A new tentative return date has been set for early July. NASA has confirmed that the Starliner will remain docked at least until July 2nd. This decision is linked to a rescheduled spacewalk, initially planned for June 13th, Th, which was the original cause for the delay of Starliner's departure. Further complications led to the postponement of the spacewalk itself. NASA officials have stated their intent to carry out this critical extravehicular activity before allowing the Starliner to undock. This extended mission continues to develop, and more updates from NASA are anticipated. Stay tuned as we navigate the unfolding developments in this celestial drama. Collecting data from the Starliner's service module has become a crucial task as NASA seeks to unravel the causes behind the series of technical issues plaguing this mission. "We are letting the data drive our decision-making," stated Steve Stitch, NASA's Commercial Crew Program Manager, during a recent press briefing. He emphasized the focus on addressing the small helium system leaks and the suboptimal thruster performance observed during the rendezvous and docking phases. With the mission unexpectedly extended, NASA is planning an agency-level review of the Starliner before it finally departs. This thorough evaluation will ensure that all systems are fully understood and functioning as expected before the spacecraft is cleared for return to Earth. Meanwhile, Boeing's Vice President, Mark Nappy, views the extended mission duration as a beneficial pause. This is an opportunity to fully understand the system's performance without the pressure of schedule constraints. "We have the time, and we'll let the data guide our decision-making." Boeing aims to conduct exhaustive testing on the service module while time permits, as once it's jettisoned, it will be irretrievable, burning up upon re-entry into Earth's atmosphere. The Starliner is equipped with 28 reaction control thrusters, 5 of which have shown issues and are located in the rear-facing segment of the service module. Additionally, of the 8 thrusters designed to propel the spacecraft forward, 1 was deactivated during docking when its thrust reading dropped to 0, leaving 7 operational. This situation underscores the challenges and critical importance of the ongoing tests and reviews. On June 15th, a pivotal test was conducted on the Starliner's thrusters, each being hot-fired for 1.2 seconds. This procedure was monitored closely by the ISS navigation system, which evaluated the impact each thruster had on the massive 1 million-pound space station. The results were encouraging. All 7 thrusters performed within expected parameters, suggesting they were operational but prone to overheating during intense usage scenarios like docking. This overheating could cause the hypergolic propellant within the thrusters to vaporize. Such a change in state might disrupt the mix with the self-combusting oxidizer, leading to reduced thrust outputs, a critical issue when precision is paramount. Despite these challenges, the extended testing period is proving invaluable. Boeing is gaining deeper insights into the Starliner's operational intricacies, which is crucial for future missions. It's worth mentioning that the Starliner first launched in 2019 with a subsequent mission in 2022, giving Boeing ample time to iron out these issues. Yet, space exploration is notoriously unforgiving, and even seasoned players like SpaceX have faced their share of dramatic setbacks, rockets exploding mid-air, yet still providing crucial data to refine future launches. Conditions are aligning for a Starliner landing as early as July 4th, a fittingly patriotic date, given that the Starliner is designed for terrestrial landings rather than ocean splashdowns. The spacecraft must catch a precise timing window to reach the ideal landing zone at the White Sands Space Harbor in New Mexico, a window that opens just once every 4 days. Although it's said that the Starliner can stay docked at the ISS for a maximum of 45 days, the specifics behind this timeline remain a bit murky, including how rigid this limit is. NASA, in their latest communication, underscored the flexibility of the situation. So far, we don't see any scenario where Starliner is not going to be able to bring Butch and Sunny home. We're just taking a little extra time to resolve the data and also learn as much as we can while we have the service module in orbit, stated Steve Stitch. In another notable development in the aerospace sector, the state-owned Shanghai Academy of Spaceflight Technology has marked a significant achievement with the successful test of a new rocket booster design. Conducted in the Gobi Desert on June 23, RD, this test involved a vertical takeoff and landing using 3 methane-burning rocket engines, showcasing another leap forward in reusable rocket technology. The new rocket booster from the Shanghai Academy of Spaceflight Technology recently achieved a significant milestone by reaching an altitude of 12 kilometers before executing a flawless touchdown at a designated landing site. Impressively, this feat was captured in video footage, although some critical moments were edited out due to restrictions. Despite these omissions, the video shows a remarkably smooth flight. Interestingly, the booster operated without movable fins for steering, relying on at least one engine that remained active throughout the flight. This approach mirrors the early experimental phases of SpaceX, notably with their Grasshopper prototype in 2012 and the Starhopper during the early days of Starship development in 2019. This indicates that the Chinese aerospace efforts are closely following a proven path toward reusable rocket technology. Looking ahead, the next test is set to push boundaries further by aiming for a 70-kilometer altitude, incorporating dynamic IC grid fins for enhanced steering control. An ambitious orbital test flight is scheduled for 2025, with the rocket expected to deliver up to 6.5 tons into a sun-synchronous orbit at approximately 700 kilometers. Additionally, the burgeoning commercial rocket sector in China might see its first orbital landing sooner than anticipated. The company Deep Blue Aerospace is on track to launch and land its Nebula 1, a 2-stage rocket with a 3.35-meter diameter and 9 variable thrust 3D printed engines, within the year. This marks another exciting chapter in the global race towards advanced, reusable space technologies. Deploying 2 tons to low Earth orbit, reusable first-stage boosters could greatly benefit China's space program. Just last week, we witnessed a video of a Long March 2 first stage crashing back to Earth, landing in a populated area. Having a rocket fall from space and crash into a town is catastrophic, made worse by the fact that the Long March 2 uses hypergolic propellants. The colorful gas seen pouring from the wreckage is a highly toxic mixture of nitrogen tetroxide and hydrazine. To understand the danger, consider the Nedeline catastrophe at the Baikonur Cosmodrome in 1960, where a hypergolic engine malfunction resulted in up to 300 Soviet fatalities and many more poisoned. China's older launch sites, built deep inland to hide from the Americans during the Cold War, now have densely populated areas under their flight paths, regularly experiencing falling space debris. But let's shift our focus to the European Space Agency's ESA latest achievements. The ESA's new heavy launcher has completed its testing phase, marking a significant milestone in Europe's space exploration endeavors. This new launcher is set to enhance the ESA's capabilities, allowing for more ambitious missions and greater payload capacities. With the successful tests behind them, the ESA is poised to take its space missions to new heights, contributing to the growing landscape of global space exploration. The Ariane 6 rocket has passed its final testing milestone and is now set for its inaugural flight in July. On June 21st, the ESA conducted a successful wet dress rehearsal at the launch site in French Guiana. This test involved fully fueling and preparing the rocket for launch, running the countdown timer up to just before ignition. While the engines were not actually fired, this rehearsal confirmed that all pre-ignition systems are functioning as intended, with everything going according to plan, according to ESA. The Ariane 6 is crucial for European space endeavors, especially since its predecessor, the Ariane 5, made its final flight nearly a year ago. Additionally, Europe's smaller launch vehicle, the Vega C, has been grounded for over a year and a half following a failure. Compounding these challenges, Europe lost access to the Baikonur Cosmodrome and the Soyuz rocket due to the Russia-Ukraine conflict. Developed under a contract from ESA and manufactured by the Ariane Group based in France, the Ariane 6 represents a significant advancement. With up to 4 solid rocket boosters, it is comparable to the new Vulcan Centaur rocket from ULA, boasting a maximum capacity of just under 22 tons to low Earth orbit and up to 5 tons to geostationary orbit. These launches will exclusively take place from the ESA's facilities in French Guiana, reinforcing Europe's independent access to space and ensuring continuity in their space missions. Launching from the Guiana Space Center in South America provides ESA with an invaluable equatorial launch site, something not possible from mainland Europe. However, this location also presents logistical challenges, particularly in transporting payloads to the site. The journey of the James Webb Space Telescope, for example, was notably arduous and fraught with complications. ESA is aiming for July 9th as the date for the first orbital launch of the Ariane 6 rocket. This inaugural mission will carry 8 CubeSats to be deployed into low Earth orbit and 5 additional payloads that will remain attached to the rocket's upper stage. Moreover, the launch will include 2 re-entry capsules, one developed by the Ariane Group and the other by the Exploration Company. A European startup recently awarded an ESA contract to establish a commercial cargo space program. Boeing's CST-100 Starliner, designed to transport astronauts to and from the International Space Station, has hit yet another snag. Despite a successful uncrewed test flight to the ISS in May 2022, the spacecraft's crewed missions remain indefinitely delayed. What's causing these persistent postponements? Sources suggest technical challenges and safety concerns are at the heart of the matter, underscoring the complex nature of human spaceflight. The technical issues plaguing Starliner are not minor. From software anomalies that led to near-mission failures to problems with its propulsion system, Boeing has been battling to ensure the spacecraft's reliability and safety. Each delay, while frustrating, serves as a reminder of the rigorous standards required for space travel and the non-negotiable nature of astronaut safety. The delays have financial ramifications not just for Boeing, but for NASA and other stakeholders. With millions invested in the Starliner program, each setback can translate into significant financial losses. Moreover, NASA's dependence on Russian Soyuz spacecraft for astronaut transport is becoming increasingly costly, emphasizing the need for a reliable domestic alternative. Amidst Starliner's struggles, SpaceX's Crew Dragon has soared, successfully completing multiple crewed missions to the ISS. This puts additional pressure on Boeing to perform, as they find themselves playing catch-up in the private sector space race. The competition underscores a broader narrative of innovation and ambition in the new era of space exploration. What's next for Boeing's Starliner? Boeing remains committed to resolving the spacecraft's issues and advancing towards a successful crewed flight. The aerospace community and its stakeholders are watching closely, hopeful that the next test flight will mark a turning point in the Starliner saga. The delays and technical challenges facing Boeing's Starliner have also impacted public perception. With each setback, questions arise about the reliability and safety of commercial space travel. Maintaining public trust is essential not just for Boeing, but for the entire aerospace industry, as it seeks to expand human presence beyond Earth's orbit. In light of the delays and technical issues, regulatory bodies like NASA and the FAA, Federal Aviation Administration, have intensified their scrutiny of Boeing's Starliner program. Stringent reviews and inspections are being conducted to ensure that safety standards are met before the spacecraft can resume crewed missions. This regulatory oversight is crucial for maintaining the integrity of space operations. Boeing's challenges with the Starliner have prompted collaborative efforts within the aerospace community. Engineers, scientists, and industry experts are pooling their knowledge to address the technical hurdles and ensure that lessons learned contribute to the future success of not just Starliner, but all spacecraft. Looking ahead, the successful resolution of Starliner's issues could pave the way for renewed optimism in the commercial space sector. As Boeing works tirelessly to rectify its setbacks, the industry as a whole stands to benefit from enhanced safety protocols, technological advancements, and renewed public confidence. The outcomes of Boeing's efforts with the Starliner extend beyond national borders. International collaborations in space exploration rely on reliable transport to and from the ISS, making the success of Starliner crucial for maintaining these partnerships. Delays affect not just Boeing and NASA, but also their global counterparts invested in the future of space exploration. The journey of Boeing's Starliner serves as a source of inspiration for future generations of scientists, engineers, and space enthusiasts. It underscores the importance of resilience and perseverance in the face of adversity, inspiring young minds to pursue careers in STEM fields and contribute to the next chapter of human space exploration. As the aerospace industry evolves, so too does its impact on Earth's environment. Innovations spurred by the Starliner program may lead to more sustainable space travel technologies, reducing the ecological footprint of launching and maintaining spacecraft in orbit. Addressing these challenges aligns with broader global efforts toward environmental stewardship in the pursuit of space exploration. From aerospace engineers to investors and policymakers, stakeholders worldwide are closely monitoring Boeing's progress with the Starliner. The successful resolution of technical issues is not just a matter of corporate pride, but also impacts financial forecasts, industry competitiveness, and national prestige. The diverse perspectives and interests involved highlight the broader implications of space exploration beyond scientific and technological achievements. Ethical dilemmas in space exploration, including safety protocols, equitable access to space resources, and the preservation of celestial environments, are increasingly relevant as commercial ventures expand. Boeing's efforts with the Starliner underscore the importance of ethical decision-making in shaping the future of space policy and governance. Space exploration transcends borders and cultures, serving as a unifying force that inspires awe and curiosity worldwide. The challenges faced by Boeing's Starliner resonate globally, reflecting humanity's collective aspirations to explore unknown frontiers and push the boundaries of what is possible. The success of Boeing's Starliner depends not only on technological prowess, but also on fostering public support and engagement. Outreach efforts, educational programs, and transparency in communication are vital for maintaining stakeholder trust and garnering enthusiasm for future missions. The journey of Boeing's Starliner also prompts discussions on public policy and space governance. Regulatory frameworks, international agreements, and ethical guidelines must evolve alongside technological advancements to ensure the responsible and equitable exploration and utilization of space. The decisions made today regarding the Starliner program will shape the future of space governance for generations to come. Beyond scientific and exploratory goals, the commercial viability of Boeing's Starliner plays a crucial role in shaping the aerospace industry's future. Success in overcoming technical challenges could bolster Boeing's position in the competitive market of space tourism, satellite deployment, and commercial space transportation. the setbacks and successes of Boeing's Starliner program offer valuable lessons for the entire aerospace community. From resilience in the face of adversity to the importance of rigorous testing and safety protocols, these experiences contribute to a collective knowledge base that strengthens future space missions and advancements. The challenges faced by Boeing's Starliner highlight the necessity of international collaboration in space exploration. Partnerships between nations, space agencies, and private enterprises are essential for pooling resources, sharing expertise, and achieving ambitious goals that benefit humanity as a whole. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.